Let's investigate the electric charge of the T-quark decay. And so here's the T-quark. Let's first look at the T-quark and see if it has the appropriate electric charge according to the standard model. So here we have a generic D-quark, and the charge is given as minus 1/3 by this generic anti-T. Then we have two anti-V's, which each have a electric charge of 0. Then if we look at our boson plus, then we'll see that the electric charge is plus 2/3 and 1/3, which gives us an electric charge of 1. Now sum with the minus 1/3 of the generic D, that gives us 2/3. And this boson 0 pair contributes nothing to the electric charge. So the 2/3 electric charge is correct for the T-quark of the standard model. Now, the T-quark emits a W plus boson. And we can see that the plus 1 charge is carried away, and it is combined with a boson 0 that contributes nothing to the electric charge, and also a vector boson here that contributes 0 to the electric charge. So for the boson plus, we have an electric charge of 1. And since we started with 2/3 and we emitted 1/3, we have a D-quark, and this D-quark, generic D-quark, carries the electric charge of minus 1/3 that we had on the original generic D-quark. And we have a boson 0, two boson zeros, one providing the flavor charge, which we'll talk about later, but the other, neither of these are contributing to the electric charge. Now we can also look here at the anti-T, and we'll see that its charges are the exact opposite. Electric charges are the exact opposite of the T-quark. Now let's look at the decay product, which is the B-quark. And so now the B-quark, as we said, has minus 1/3 on the generic D, and the boson zeros then contribute nothing to the electric charge. So the electric charge is minus 1/3, which is correct for the B-quark, according to the standard model for the electric charge. Now we're going to investigate the spin quanta. So again, starting with the T-quark, we will see that the generic D has a spin of plus 1/2, minus 1/2, and minus 1/2, which sums to minus 1/2 on the generic D-quark. Look at the boson plus and the particle-antiparticle pair. They each have opposite spins, so they contribute nothing to the spin. So the initial spin of the T-quark is minus 1/2. And so then we have emitted the boson plus. And the boson plus has a scalar part that carries away no spin, and a vector boson part where on each of the T and anti-T generic rishons we have minus 1/2 spin. So we have a -1/2 spin summing on the boson, W boson plus, carried away from the original T quark. And if we look at the anti-T, we'll see that it begins with a right-handed spin, where the opposite of the T quark, which began with a left-handed spin. Let's look at the decay product. And again, we can look at the boson 0. It's scalar, contributes nothing to the electric charge, and also the boson, this boson 0 here, 1 having the flavor charge, which again we'll talk about in a different video. But if we look at the generic D quark, and we see that the spin on the anti-T generic Rishon has changed, and from -1/2 to 1/2, and so that the sum of spins on the generic D quark now are 1/2, -1/2, and 1/2 would sum to 1/2, which should be the correct spin on the B quark, since a -1 spin was carried away by the W boson. So now we will look at the weak isospin, which is associated with spin. And so for a left-handed T quark, the standard model predicts that there will be weak isospin carried by the quark. And so we look at the generic D, we can see that there are isospin quanta of -1/3 on the anti-T Rishon, and on the anti-V Rishons we have a +1/6 and a -1/6, and the sum of these will be -1/2. A -1/2 is the weak isospin that we should expect on, we should not expect actually on the generic T quark. It should be a +1/2. But if we look at the boson plus, we can see that it has a 2/3 and a 1/3, and which is weak isospin of 1, and so summed with the generic D, that'll give us the 1/2 that is required by the standard model. And then the other particle-antiparticle boson 0 will contribute nothing to the isospin. And then if we go here and we look at the W boson that was emitted with the vector 0, we would expect to be carried away that +1/2 spin. Again, the boson 0 doesn't contribute anything here, but the boson plus carries away the weak isospin of 1. But the vector boson actually has on it a weak isospin of -1/2, and so that sums to +1/2, which was the weak isospin that was on the T quark, being carried away now in this W boson configuration. And on the now spin +1/2 B quark, we'll see that on the generic T we have a 1/6, 1/6, and a -1/3, which will give us 0 for the +1/2 spin generic D quark, which is the correct spin that we should have on a right-handed particle according to the standard model. And if we take a look at the antiparticle below, we'll see that its weak isospin numbers will be the opposite of the T quark above, and so it will be consistent with the standard model. And so there we have a description of the electric charge, spin, and weak isospin as the composition of the rishons give a consistent accounting according to the standard model.